Good afternoon and welcome to the Johnson Space Center for the Expedition 4849 Crew News Briefing. Before we get started, we did have one kind of technical note for you all. We may be experiencing some interference in the television signal today, but we'll be recording the briefing and we'll be replaying it on NASA TV throughout the day. So if you miss any of it, you can tune back in a little later. So now we're going to introduce the crew who is here with us today. We have the Expedition 4849 crew members, and we're going to start with NASA's Kate Rubins. This is her first mission to the International Space Station, her first trip to space at all. And so Kate, maybe you can start a little bit by telling us what you're looking forward to as a science, since you have such a scientific background.
Yeah, we actually have an amazing complement of science on Expedition 48 and 49. There's going to be over 250 different science experiments, so it's a little difficult to choose which one. There's definitely a lot of life science experiments that I'm pretty excited about. There's going to be some DNA sequencing experiments, a lot of experiments to look at the behavior of cells in space, as well as bone loss and muscle loss that we can actually correlate with some diseases on Earth. So I'm looking forward to a pretty hefty research component on 4849.
Okay, well, next up we have Anatoly Ivanishin, who is the Russian cosmonaut on the crew, and he is actually the experienced member of the crew. He's been to the space station before, so Anatoly, maybe you can tell us a little bit about what you've been able to give your crewmates in terms of tips for getting ready for going to the space station.
I think that my crewmates are ready for going to the space station, and the better advice I can give to them is to keep their eyes open. Have fun and enjoy the time you spend in space, because the time is going to pass very fast.
Okay. And finally, we have Takuya Onishi, who is the Japanese Aerospace Exploration Agency member here. He'll be a flight engineer on 48 and 49 as well. And Takuya, maybe you can tell us a little bit about the training you've been involved in so far.
Yeah, I'm in the left seat of Soyuz space vehicle, so I spend almost half of my time in Russia, and the other half of my time in here at Houston. So I've been very busy for these 2.5 years since my assignment, and the training for Soyuz vehicle was quite tough, because I needed to study like a college student. I stayed up late almost every day, like up to 2 a.m. studying Soyuz systems and going to classes on the daytime, and come back and study again. So it was very challenging for me, but I enjoyed the training itself.
All right, well, with that kind of schedule, we really appreciate y'all making time to talk with us today. We've got just a little bit of time today, and we've got a number of media here in the room, so we're going to start by taking questions here, but we also have reporters on the phone bridge who will be joining us. For those of you who are joining by phone, you can press *1 to ask a question, and if your question is answered, you can press *2 to withdraw it. And then finally, if you are watching and participating remotely, you are welcome to ask questions via social media. You can use the hashtag AskNASA, and we'll have someone in here in the room to ask it on your behalf. All right, let's start, though, with our media questions. If you can make your way to the microphone, we'll get started on those.
Hi, Eric Berger with Ars Technica. Question for Kate. I remember, 5 years ago you were following the crew of STS-135 around, and now you finally made it. Maybe talk about a little bit about kind of the expectations that you have for space, and kind of, how long you've been sort of training and waiting and to get to this point.
Well, I thought I made it when I was finished ASCAN training. I got to hang out with the crew 135. That was pretty amazing. But we have been training for quite some time. So we trained for 2 years after we're initially accepted as astronaut candidates at NASA. And then we spent a few more years just understanding all the technical parts of the job. Once we're mission assigned, it's about a 2 to 2.5 year flow. So it has been quite some time. It passes by really quickly. I think spaceflight's going to pass by at a similar speed. So I'm looking forward to the mission. There's a lot of things I'm looking forward to. I think the science is going to be really exciting. We're going to have some opportunities to have visiting vehicles. A lot of our commercial partners are going to be sending different cargo vehicles up. And I think there's probably not too many things on a day in the life of space station that aren't absolutely amazing because of the fact that you are in free fall the entire time and the laws of physics have changed. So I'm looking forward to seeing all of that.
All right. Reminder to the media here in the room that you can make your way up to the microphone for more questions. While we're waiting, Kate, I know you've been to a number of kind of extreme environments in the course of your career before NASA. Do you feel like those have prepared you for space, or is it going to be very different?
Well, I think each environment's pretty unique, but it is right. We do a lot of training during our assigned crew flow and also before we're assigned to survive in an extreme environment. And so the kinds of things that you do to take care of yourself and take care of your crewmates is really important. We got an opportunity to do water survival and winter survival together. And you learn a lot about yourself, and you learn how you can be part of a team and work together in an expedition. So that's actually sometimes one of the really fun parts of training. And I think it's going to be incredibly fun for us as a crew on orbit as well.
All right. Go ahead.
Hi, Robert Perlman with CollectSpace.com. You'll be launching on a new class of Soyuz, the MS. Can you talk a little bit about what that's done to your training load? And you were originally assigned to the TMA-20M, so what was the differences in stepping up from the older Soyuz to the newer one?
Yes, we had to fly new Soyuz MS. And you know that the history of Soyuz spacecraft has, I think, almost 50 years. Its maiden flight, Soyuz spacecraft, performed in 1966. That was unmanned flight. And since then, we have four generations of Soyuz spacecrafts. Actually, we are flying the fourth generation. Yes, we were to fly the last vehicle in the previous series, but due to some changes, actually, Alexei Ovchenin, Alex Skripachka, and Jeff Williams to fly our vehicle, and we kind of took the air. You know that we have manned and cargo ships, Soyuz in progress, which share the general design idea, the general architecture, and most of the equipment. And there is a rule that all the equipment before it is flown on Soyuz should be tested on Progress first. As well, we need to have 2 successful Progress flights in a new series before we have a goal for a new Soyuz flight. So we have a Progress MS-01 in space. It was docked successfully. And we expect the second Progress MS-02 to start on the 31st of this month. And with its successful launch, our road to spaceflight will be open. So what are the differences the new vehicle exposes? There have been some changes. We have new engine arrangement. Now we have 2 manifolds of attitude control engines, and should we have failure in one of the manifolds, we have a backup, so we have good redundancy. We can perform any operations on the second manifold. We have new system which allows the vehicle to be commanded from the ground, to send telemetry, to have voice exchange, and even to transfer files using satellite constellation Luch 5, which kind of tethers. And I think that 70% of the orbit, the vehicle will have the ability to talk with the ground, to be controlled by the ground. We have new radar. It has become more reliable, less weight, and as a result, we have changes in the rendezvous profile. Now we will turn it on later on less distance than we used to. because we kind of have enough statistics. We can rely on the flying without the radar for some time. And this radar allowed to reduce the number of antennas. Now we have just 1/2 we used to have. What else? We have new backup manual control system. I'm talking about the motion control. And what did I miss?
You covered all. From my point of view, I'm hearing that differences between the old vehicle and the new vehicle, those are not so big and not so many from a crew's perspective. So I think we have enough time to get ready for that new vehicle and, until the launch. And since 2014, we've been going through many simulations as a crew. So we already know that how to work as a team, and we know each other very well. So it's just difference in the procedures from my point of view. So I'm not worried about anything.
All right. Well, I think we've got another question here in the room now.
My name is Makoto Mitsui from the Japanese newspaper, the Yomiuri Shimbun. And my question goes to Ms. Kate Rubins. And question is about what kind of message do you have for young women who are considering or are in the STEM field? And another question is, what are some of challenges women must face to be successful in STEM field?
That's a great question, and we do a lot to help young women at NASA here get interested in science and engineering fields. And my advice was, if you're thinking about it, that's great. Go with that, pursue that. And if that's your passion, I think there's a lot of opportunities. There's certainly a lot of opportunities at NASA. There's opportunities in engineering and science. And if you find something that you're excited about and you're interested in, my advice to young women and young men would be, do what you're really interested in and what really drives and motivates you. And in terms of barriers, I think there are barriers. Sometimes there are lower numbers of women that are in the senior faculty range. So finding folks that can mentor you is extremely important. But I think that we've got increasingly more and more opportunities, and we are seeing a lot of young people that are really captivated by science and are interested in space science and the kind of engineering that we do at NASA. So that's one of the great part of our jobs, is that we get to see this and meet some of these young folks that are really excited about science and space.
Okay, thanks. Just a reminder, if you're on the phone and you have a question, please press *1 to let us know. And if your question is answered, you can press *2 to withdraw it. And another reminder also that we're taking questions via social media, so you can use the hashtag AskNASA to get your question in, and we'll voice it here in the room for you. We can still have questions from here in the room if anybody has one ready, but in the meantime, Takuya, maybe you can tell us a little bit about your experience with NEMO.
Okay. So I was a part of NEMO mission. For those who don't know about NEMO mission, that's one of NASA analog mission for space flight, and we've done it underwater. And we were supposed to spend 2 weeks in the research lab of underwater, like offshore Florida. But unfortunately, our mission was shortened by a week because of a coming typhoon. But we had a great time. Then I was told by a JAXA astronaut, Koichi Wakata, and he told me that NEMO mission is one of the best analogy for space flight. And I totally agree now. And I thought it was so great experience for me to be a part of that mission. The timeline each day was full. We was very busy doing EVAs and preparing for next EVA, having conference with the ground team, communicating with the ground team. So all aspects of that mission was, I thought, very similar to space mission.
Do you feel like that helped you get ready for the experience coming up?
Yeah, definitely. Yeah.
Great. All right, well, next up, I think we have some guests here in the room with us from Rice University, some young women who are going into STEM fields themselves, and I think they had a few questions for us. Go ahead.
Hello, Ray Holcomb from Rice University. A question for Dr. Rubin. You've had extensive experience with laboratory research during your career. Can you tell us about the scientific process and how it differs when performed in space?
Yeah, that's a great question. The ISS is a laboratory on board. One of the things that differs a little bit is that the laboratories on Earth are extremely specialized. So you spend your whole career or many years doing one particular experiment, whereas on board the space station we have hundreds of investigators from all over the globe that are sending their experiments up. So you start to be a little bit more of a generalist than a specialist. But we've had some training. I just had training this week, for example, that's looking at how we're going to grow different kinds of cells on board, and how we're going to be taking a look at the different kinds of cells that form your bone mass. And that's pretty similar to what I spent about a decade doing in the laboratory back on Earth. So I felt right at home. I think the interesting thing is going to be when everything starts to float up and you need to figure out how to tape it down and how to get your bench work done with the lack of a gravitational vector.
Mm-hmm. Go ahead.
I'm Jim Oberger with Spectrum Magazine. Your comment raised a question about your water survival training because it's been winter in Russia for a few months. When and where did you do your water survival training?
Where did we do?
Yeah, where and when?
It was some place not far from Moscow.
Not far from Moscow. Okay, so you broke the ice, or was it in the winter time?
No, actually we have two kind of survival training which are mandatory for Soyuz space flights. These are water survival, which is always done during the summer, and winter forest survival.
That's good. Thank you very much.
All right. If you have another question, you come on up to the microphone. But in the meantime, Anatoly, maybe you can tell us a little bit about what you're looking forward to getting back to at the space station.
I'm looking forward to, entering again the space station. I left just in 2012. It looks like it was yesterday. So I'm going to be a part of the crew and perform scientific research, maintain the station, and I'm pretty much sure that the time will fly, and we'll do something really interesting and which will help to promote our science.
Sounds like a good plan. All right, any other questions here in the room? Maybe we can take some from Ask NASA at this point.
So this question comes to us from Charles on Twitter, and it can be for anyone. How do you plan to engage people on Earth while in space?
How do you plan to engage people on Earth? I wish the project of International Space Station could be a good example for people on Earth, how successfully can be different nations when they combine their efforts in order to achieve a common significant goal. And we have some examples in this way, starting from Soyuz Apollo mission through Shuttle Mir program and here International Space Station, which has been with us for quite a time, and I'm pretty much sure the project will go on at least until 2024. And I consider this project as a solid foundation for our future endeavors in space exploration.
Okay, I think we have more.
This can also be for anyone in the crew that wants to answer. It comes to us from Bob O'Dare Jr. on Facebook. Are there any spacewalks planned for this mission? And what tasks will you be completing on them?
Great question.
That's a good question. So the schedule as it is baselined right now does have a few spacewalks for this mission. Some of the things that are really important pieces of hardware that are coming up for the space station are the International Docking Adapter, And that's going to allow us to dock for future commercial crew vehicles to the space station. So that's going to be really exciting to be able to bolt that onto space station. We hope to accomplish that during our mission. We're also getting another set of batteries that's going to be installed out on the truss segment of the space station. And so power is everything in space. It's solar powered, which is it's really neat that we have a vehicle that's entirely powered off of solar power, and it's a huge vehicle. So we're going to get the opportunity, hopefully, to change out those batteries as well.
Okay, keep coming to the microphone as you have questions. But Kate, maybe you can tell us a little bit about the training that's gone into those spacewalks.
Yeah, sure. So Takuya and I train in the NBL, also with the crew on either side of us. And we get a lot of training when we're in our initial flow. After that, it starts to get more specific once we get mission assigned. So we're trained for potential contingencies on board space station, as well as any of these nominal tasks that might come up. It's about a six-hour, we call it a run, but you're not running. It's a 6-hour run underwater. You're definitely not running because you have a 300-pound spacesuit on. But we are able to be neutrally buoyant, and that's how we can simulate as best we can microgravity here on Earth and do all the training for spacewalks.
In 6 hours, sounds like a long time to go without a break. Is that at all taxing?
It's about 2 marathons worth. And when I'm on Earth, I run 1 marathon and call that good. So yeah, it's a challenge.
But I guess it gets you ready for the real thing in space.
It does, yep.
Okay. All right, Eric?
Hi, Eric Berger again. Kate, with your background in infectious diseases, maybe you could talk, I'm not going to ask you to pick a favorite experiment, but maybe talk a little bit about some of the work you're doing and how that advances the study of biological science back here on Earth.
Yeah, that's a great question. I can't pick a favorite experiment. There's too many of them. But I did mention we've got a cell culture experiment that's looking at bone cells. And so everybody thinks of bone as this, your bones are just there and they're kind of this solid material, but they're actually a living tissue. So we're constantly breaking our bone down and we're adding to it. And when you lose that stimulus of gravity, we are going to break down more bone than we're going to add. So that's why you hear about potential bone loss on orbit. This is really interesting for Earth-based diseases as well. We've got things like osteoporosis, where you've got this accumulation of bone loss. And so the experiment on space station is designed to specifically look at cells that build up bone and how they behave in microgravity and how the differences due to lack of gravity stimulus might alter their function. So we think we might be able to learn something about Earth diseases as well.
You talked a little bit already about how it'll be a little different doing scientific work in microgravity than on Earth, but maybe you can talk a little bit more about that and I guess what the attraction of the space station as a laboratory is to somebody with your scientific background.
Yeah, it's a really neat laboratory because it's the only place that we can actually study gravity as a variable. So scientists across all disciplines throughout the hundreds of years that we've been doing science have always had gravity as a constant in their experiments. And this is really the one lab where we can actually use it as a variable. We can even alter the amount of gravity, so we could put lunar gravity or Martian gravity. We can centrifuge things. And so it's really a way to investigate what happens to physiological beings, to their individual cells and their tissues when you don't have gravity. And it's a lot of basic research, but we can understand things about physiological processes because we're using the space station and microgravity there, that we can discover processes we've never been able to before on Earth, and that we just can't test on the ground.
Sure. And I guess, Takuya, I think you have a bit more of an engineering background. Maybe can you talk a little bit about how you gear up for all the science that you'll be doing as well?
So I studied material science in my university, so I'm especially interested in material science experiments. Those are being conducted in the space station. Especially JAXA has just deployed a new piece of hardware for experiment. It is called ELF. ELF stands for electrostatic levitation furnace. And what it does is it can levitate a piece of material. Then by using laser, it can heat up the material like up to 3,000 degrees Celsius to to see how materials melt or how react to those high temperatures, like viscosity, density, and surface tension. And knowing those characteristics, we can advance our technology on the ground. For example, probably maybe a new method of production, or maybe production of a high quality material. So I'm really looking for those kind of experiments.
Thanks. Anatoly, what about you? I know that the Russians have kind of a lot of science experiments that we don't even always hear a lot about in the U.S. So any that you're particularly interested in?
There are many, but I'd like to tell you a few words about joint experiments. We are going to conduct a joint Russia-East research in the field of complex plasmas. It's a long-running experiment. I don't remember it started. It has been years. And I remember it was conducted in the Russian part of the station. Now it's moved to Columbus. So this experiment studies complex plasmas. Complex plasmas are plasmas which contain ions, electrons, neutral gases, and dust particles. Microparticles or dust grains. And what's interesting in this type of plasmas, there is a phenomena when the particles being highly charged and interact strongly with each other, so they can form a structure which is a crystal-like structure. So that's why we call this experiment crystal plasma. And what is the most what is the objective for investigation is the liquid phase of this phenomena, and the scientists are looking in like 3 different stages of this experiment. They're interested in microscopic particles of complex plasmas, like charging particles, agglomeration, and particle growth. Macroscopic properties of complex plasmas, like hydrodynamics, for example, viscosity, thermodynamics, and non-equilibrium properties of complex plasmas, and generic properties of classical many-body systems, like melting, crystallization, protons in plasma crystals, and dust waves. So plasma is found anywhere throughout the universe, and we have plasma on the thermal shield of any spacecraft re-entering the Earth's atmosphere. By the way, this is the most amazing part of the space flight. But very soon the windows will get burned and you won't be able to see everything. So this research will possibly allow scientists to shed some light on the nature of the complex plasmas, and it will have application possibly in the spacecraft designs. And though it is more fundamental research, I believe that application for the industries on the ground are also possible.
Wow. It's always amazing to hear all the different types of research that go on the space station. But I think we have another question.
This time my question goes to Kate and Mr. Onishi. So it is the first time for both of you to go to space. So what would you like to do in the space, International Space Station, except for work or except for business experiments? So in your space time, what do you want to do in the ISS?
Well, I might end up trying to do some experiments in my spare time because that's what I'm most interested in. I'm particularly interested in trying to do some sequencing of DNA on board. So that's one of the things that I think is going to be a very exciting payload that we have. I think in general, a lot of astronauts spend their time looking at the Earth. It's amazing. You go over a different part of the Earth every single orbit, and so just the opportunity to see the entire world and to be able to take photographs of that seems to be incredibly captivating. And you can see from Scott Kelly's Twitter feed, for example, just the way that it changes every day, and just the beauty of the Earth is I think, not something that any astronaut would ever get sick of.
Go ahead.
This is my first flight, and so I'm really excited about it. And I really look forward to all aspects of our space flight. So from the launch until our landing, and even how to use a space toilet in the station. I really look forward to all of them. And hopefully I can introduce this kind of our lives in the station to the public using internet, like Twitter or Google+. Personally, I'm doing Google+, so using it, I wanted to encourage people, or our kids, to study about space.
Thanks.
Juan de la Garza, Spaceflight Insider. This is for anyone that would like to answer it. In collaboration with your international partners, there's hundreds of experiments scheduled for your stay on board. How are they distributed amongst every single one of you?
So we get some training on the ground, generic set of skills training so that we can function as laboratory workers essentially on board the International Space Station. And then each contributing agency gets time and resources and payload availability. That's not decided by the crew, thank goodness. There's some really smart people that do all the allocations. And then we will get some timelines and some schedules that says when we're performing which experiments. And so it's all predetermined. So we're able to wake up and we take a look at the schedule and we see what the various experiments, and it may be maintenance tasks as well, or prep for a visiting vehicle we're going to do that day. And there's always the option to help your crew member out or work on something that you're interested in. But we've got a whole team of folks on the ground that really help develop this great plan for us.
All right, and if you're watching at home, a reminder that you can send in your questions via the hashtag AskNASA. And for those on the phone bridge, press *1 to ask a question. Go ahead.
Hello, I'm H. Asami with Kyoto News, Japanese Wire. I'd like to ask all three of you, how do you evaluate yourself as a team? I also like all of you to describe the other two as a colleague. Thank you.
I think that we are a team. We have been together in training for, I think, 2 years and a half. We have very interesting experience of being in survival training under circumstances when you can really see the people with whom I'm going to fly, and I was really very happy to go through this training. And well, both of my crewmates are very educated, very hardworking people, very easygoing. And during our winter survival, both of them were really helpful. Kate is a scientist. He come up with the solution. Actually, for winter survival, we have to spend 2 days in Russian winter forest, and the temperature is significant, not as warm as in August in Houston. And actually, we had to build 2 different types of shelters and spend 2 nights there. And well, Kate was very inventive. She came up with the solution how to build a structure of cotton wood around the fireplace, so we were able to get them drying better. And Tak was also very helpful, and I very like Tak as my Soyuz flight engineer. I can rely absolutely on his. Actually, we share with him the responsibility to deliver our bright scientists to the station. and I'm very happy with the performance he has shown during our training. Kate, I know that Kate has two dogs named after first Russian space dogs, and you have to have some skills in Russian language in order to get the flavor of these names. And Taksan have two kids, and you know that in Soyuz vehicle, usually the vehicle is very reliable, but every crew find that the equipment set is not complete. Usually one instrument is missing, a very important one, and this is a weightlessness indicator. And since Tak has two little kids, I think he will find how to help us with this device.
Really? I didn't know that. Okay. Yeah, that'd be great. Thank you. Yeah, I think we are a good team. I can trust these two guys more than 100%. 2 days ago, we had emergency training, but we went through as many as 5 scenarios without any single problem. So we've been trained as a team very well. And for me, Anatoly is very experienced, and I like his style of work. He's always calm. Even if we have fire and rapid depressurization in Soyuz vehicle at the same time, so I like his style, and he always gives us good advice to Kate and me. And Kate, she has totally different sets of point of view compared to Anatoly and I, because she was a researcher, and sometimes I was pretty much impressed by what she was how she looked at experiments or our training itself.
Okay, Kate, did you want to
Yeah,
follow
well,
up?
you expect and you hope that everything goes according to plan, but if it doesn't, these are the two guys that you want to be with you in your spacecraft. So I feel pretty lucky. You end up forming a team with your crew, and it's really important. These are people you're going to be spending a lot of time with, and so I just feel incredibly fortunate to be able to fly with these guys, and I'm really looking forward to it.
And I know it's not incredibly unusual, but y'all got a very international crew as well. Were there any, barrier or cultural barriers that surprised you or that you had to overcome?
I have not mentioned any so far.
No? Right. Okay, I think we have one question on the phone bridge now, so we're going to go to Sarah Lewin from space.com.
Hi, so for anyone who wants to answer, what was the most challenging thing you did during your long training?
Yeah, for me it was Soyuz training, and so training style in Russia is a little bit different from training style here in Houston. For example, I always use this example to explain the difference. And let's say you need to learn how to use microwave, and here in Houston, they only teach us like we just need to open the door, then put a dish inside the microwave, then select time and push heat start button. That's all. Then if we have any problem with the microwave or heating, just let the ground team know. That's how Americans or NASA teaches us. But there in Russia, it's totally different. They start teaching us what's the principle of physics, how we can heat up things using a microwave. So that was a lot of studying almost every day from like 8 a.m. to 2 a.m. So it was quite challenging for me.
As soon as you are assigned to crew, we start traveling all around the world, and that's also kind of challenge because you have to shift time zones quite frequently and quite significantly. We have, I think, 9 time zones between Russia and between Moscow and Houston, and in the challenge. Language issues have always been a challenge for me. It's really difficult, and by the way, Taksan speaks perfect Russian and English, both languages, and I really believe that he goes to bed at 2 a.m.
Well, for me, at the beginning, the challenge was integrating everything. You go through this 2.5-year training flow, and you see a little slice of everything. So we need to be able to do anything and everything on board. We need to understand all of the equipment, how to fix it. So you show up for work, and one morning you're a plumber, and the next morning you're a dentist, and then you're going to be a scientist, and then you're a spacewalker. And so you have to be pretty detail-oriented and be able to be a little bit of an expert in each one of these areas. During the course of the training flow, they start to bring that all together, and by the end, you definitely get comfortable and you really feel prepared for anything that may happen during the increment. So I think that's really a testament to the training team and how they bring all of this together. And the key is to just let them do their job, and we'll turn out trained crew members at the end.
Okay, I think we're just about out of time, but maybe we have time for one more social media question.
Definitely, and this one may require a little bit of explanation for people not familiar with acronyms, but Ben Evans is asking on Twitter, will the crew do any work inside Beam during your expedition, and what tasks will you perform?
Yeah, so we're hoping that we're going to be doing some work in Beam, and it depends a little bit where it falls. We're actually hoping Tim Copra and Tim Peake get it all nice and outfitted for us, and we can just be part of the experiment. But we will probably be doing some sensor installation. We are going to be looking at the pressure shell. We're going to be looking at radiation and a whole bunch of different parameters to evaluate these types of vessels docked to space stations. So I think it's pretty exciting. It's something really new and interesting that we're doing, and we're definitely looking forward to wherever that falls in our increment.
And maybe you could explain a little bit more about what Beam is.
Yeah,
as
I'm
well.
sorry. That was the first thing, right? I jumped right into the NASA acronyms. So Beam is actually an expandable module that Bigelow is going to send up, and so that's going to be berthed to the space station. It's an inflatable module. This thing sounds very scary at the beginning because you picture blowing up a balloon, but it's actually an incredibly hard pressure shell, and then we'll be outfitting with sensors to analyze how that pressure shell is reacting in the space environment over time.
Okay, I think that's probably all the questions we have, unless there are any more. Don't see any. So the crew is going to be launching to the International Space Station from the Baikonur Cosmodrome in Kazakhstan on June 21st, and then they'll be spending their time there all the way through October. So you'll want to follow along with that. You can catch updates at nasa.gov/station, and we'll be watching that for more. Thanks so much for joining us.